if the Earth's temperature as a whole isn't changing too drastically, that means that the amount of heat we're losing in the colder areas near the poles is going to be roughly similar to the extra heat being gained in the warmer areas near the equator. So, near the equator, again, the sun gets high in the sky in the middle of the day every day, and so the Earth's surface is gaining more heat there. This means the air is typically warmer in the oceans. The air is warming up the ocean because of that temperature difference. As we move more towards the poles, more than roughly 30 degrees or so, in these regions, the sun doesn't get as high in the sky, and so the ground doesn't warm up as much, or the ocean surface. More heat is being lost out into space than is gained in those areas. Typically, the ocean water is warmer than the air in these areas. But of course, we've got winds, we've got currents, and so as these move things around, we move the extra heat from the areas near the equator into the high latitudes towards the poles. So with this, again, no surprise, we all know it tends to be warm near the equator, but looking more at the pattern, we have zones going from the equator towards the poles of warmer and cooler climates. As we change our latitude, whether it changes your attitude like Jimmy Buffett claimed, well, maybe, maybe not, but it certainly changes your temperature. But something else can change our temperature: elevation. As we go up and down, if we go higher up, the average temperature gets less. Now, just say up and down on campus, that's not a big enough distance. Maximum difference from highest to lowest point on campus is probably not more than about 200 feet. If you count climbing, say, up to the top of the steeple or something, you could probably make it more like 300, but basically not that huge a variation there. But if you get more towards say a kilometer up or down, that's typically going to be big enough to have a noticeable change. Tall enough mountains, or going up in an airplane, you can go actually through several climate zones just as if you were traveling from the equator towards the poles. Himalayas, it's fairly warm there at the base, but as you get up to the top, you get to polar climates. Turns out that going around 1,500 kilometers north or south is roughly the equivalent effect of going up or down by 900 meters, a change of about 5 degrees Celsius. Now, again, whether things change around, it's not constantly exactly that, but that's a general pattern. But many local features have an effect as well. For example, do we have water? Again, water has a high heat capacity. It's going to warm up more slowly, it's going to cool down more slowly. And so places with plenty of water characteristically will have smaller seasonal changes. The summers will not be as hot, the winters will not be as cold. This is part of the reason why having a place to live near the coast is often popular. It tends to be not quite so hot in the summer and not so cold in the winter. Another example of the effects of having water or not around, in Florida, they grow a lot of citrus fruits, things like oranges. At least they used to give out orange juice at the Welcome Center as advertisement. But the reason why they're grown there is because frost will kill them. They have to stay above freezing. And so, partway down in Florida, you reach the point where temperatures normally stay above freezing in winter. And you can grow these and other freeze-intolerant plants. We noted mangroves earlier as another example. Okay, but in Florida also, a lot of Florida is kind of swampy, and so people have come in and drained areas. Less water around, with that high heat capacity, that makes it easier to change the temperature. And as we've dried areas out, it's become more likely to have the temperature dip below freezing on a cold winter night and wipe out the citrus crop. So the northernmost spots where you can grow oranges has tended to move south as we've drained in Florida, removing that buffering capacity of the high heat capacity of water and making it easier for the temperature to get below freezing and wipe out the crop. Land has a relatively low heat capacity, and so in the middle of land we tend to have much more temperature variation. It gets hotter in the summer and colder in the winter than if we're near a large body of water. Not only does water have that high heat capacity, but also water is clear, so some of that light, instead of warming up the surface of the water, goes down in and warms water deeper down. So you're trying to warm or cool a thicker amount of water than basically just the surface of the land. Also, water moves around more than the land. Okay, we've warmed up some of the surface water, but that flows around and mixes. And so again, we're warming or cooling a greater depth of water as opposed to the land. Again, meaning that our water cools and warms more slowly. This leads to common patterns. Here's an example, a photo out my plane window flying over an island. And we notice the clouds are over the island, not over the ocean. Okay, we can see things. This is the daytime. Land versus water. Which one's warmed up more? Well, it's the land. Okay, so land is warmer. Air above that land's getting warmer. And that warm air expands and rises. As it rises, it cools off. It's getting higher, so temperature is dropping. Eventually gets cool enough for the water vapor to condense and make the clouds. So we tend to see rising air and clouds above land next to water during the daytime. At night, this will be reversed. A little hard to take a picture up the plane window at night, but the land will cool off faster. Now this is cooler. Air here is sinking. Air over the ocean is rising and giving the clouds there. Ocean currents also play a big role in just what your local climate is like. For example, we have a warm current, the Gulf Stream, flowing up in the East Coast, Florida, up through around Cape Hatteras, where it bends further offshore. And that keeps the temperature somewhat warmer for the southeastern coast of the U.S. On the west coast, we have a cold current coming down south, California current. So, for example, Charleston, South Carolina, and Los Angeles, California, are about equally north from the equator. But Los Angeles, July temperatures average noticeably colder, about 23 Celsius, versus 31 in Charleston. Bermuda is an island out into the inside of the gyre, surrounded by lots of ocean. It's around the same latitude as Charleston, but the average temperature year-round is quite mild. Mean in Fahrenheit, around 72, rarely gets warmer than the mid 80s or below the 50s Fahrenheit. Certainly gets above the 80s on land in Charleston, and below the 50s in winter. So much more mild climate, not much variation for Bermuda. We can see the same sort of thing if we compare, say, coastal versus inland cities. San Francisco, California versus Sacramento, not very far away, but San Francisco's by the ocean on a little peninsula. Sacramento's more inland, and the summer temperatures are much higher, and the winter temperatures get colder than San Francisco. Similarly, if we look here at Boiling Springs versus going all the way out to the Outer Banks, Ocracoke Island, our summers are noticeably warmer, and our winters noticeably colder here than the typical temperatures out at Ocracoke.